All right, here we go. So what we got here, this is number 5 in your homework, the angle proofs homework. We're going to go through this one here together, but what I wanted to do is I wanted to put up a very, very similar segment proof. So these actually are pretty much the same proof. This one's for segments, this one's for angles. And we did this in our first, or we did one like this in our first segment proofs homework. The letters might be a little bit differently, but the idea is basically the same thing. So let's kind of run through what we got here and then see if we can kind of use some reasoning that we're familiar with and apply it over here, okay? So let's start on this side. So given, and this is the picture we're working with, given AB is congruent to CD, so these are congruent to each other, okay? And we want to show that this guy, AC, is congruent to this guy, BD. And the idea here is fairly simple. It's if you have two segments that are congruent, and to each segment you're adding the same segment, then the new segments that you get have to be congruent to each other as well. So that's what we're going to show here. And we already did this one, so I'm hoping that as you went through this and you watched the video and you practiced it on your own, this one's familiar. This one is very, very similar, but it's in angles. So notice that we have two overlapping segments, right? We have AC and we have BD, and they're kind of overlapping each other. We want to show that AC is equal to BD. Well, this guy is very, very similar. We know that angle 1 is congruent to angle 3. So it's kind of like this. It's kind of like saying we have two segments on the end, and then they overlap with this middle thing, right? We have two angles on the end, and they overlap, and there's the middle angle, just like there's a middle segment here. So same kind of idea. And we want to show that CBD is congruent to EBA. So we want to show that this angle right here is congruent to this angle that's overlapping. Here. So hopefully you can see how these proofs are very, very similar, right? We got two segments on the end that are congruent. We got two angles on the end that are congruent. We want to show that this segment is congruent to this segment where they're overlapping and sharing this middle piece. We want to show that this red angle is congruent to this blue angle where they're overlapping and sharing this angle. So very, very similar. Let's run through each of them. Let's go through this one first quickly, and then we'll apply it to over here because we've already did something like this before. Okay, so first up, again, start with the given. So AB congruent to CD, given. Now we want to stop here. When we get to AC is congruent to BD, we can stop when we know we're done. So that's where we know we're going. Okay, first thing we need to do, we don't actually have to do this first, but I like to do it first because it makes sense. AB is equal to CD. Okay, we don't have to write it in this order, but we might as well do that since we have this statement. What does this statement give us? It gives us this statement, and we're using the definition of definition of segment congruence to get there. Okay. The next thing we need to do, well, there's one of two things we can do. We either need to add some angles on both sides here, or add a segment on both sides, or we need to do the segment addition postulate. Let's go ahead and just use the addition property of equality first. So what are the things I could do here? Is I could say, if I have an equation like this, I could go plus 5, right? Keep it balanced. As long as it stays balanced, I'm good. All right, that's an equation technique. We call that the addition property of equality. Okay, well, what I'm going to do instead of adding 5 and 5 is I'm going to add a measurement. I'm going to add BC. So I can do this, plus BC, right? Because BC is just some number out there. So let's do that. So I'm not going to write the word, I'm just going to write the next line. So we're going to have AB plus BC is equal to BC plus CD. And I'm not even really thinking about the picture. All I'm really doing is just adding the same thing to both sides of this equation. That's the addition property of equality. Okay? Now what I'm going to want to do down the road is do a substitution, right? I know AB plus BC equals AC, and I know that BC plus CD equals BD, and so I'm pretty much there. But before I can replace this with AC, I have to write that this is congruent, this is equal to AC. So what I'm going to do is I'm going to say, well, hold on a second, AB plus BC, isn't that just AC? Yeah, AB plus BC is AC. But how do we know that, or what property can we, or definition, or rule, or law, or whatever can we invoke? That's the segment addition postulate. Okay. Now, by the same token, we can say that, well, hold on a second, isn't BC plus CD just BD? Yes, also true. So BC plus CD equals BD. Again, segment addition postulate. Okay. Okay, so now what we can do is we can take this line right here that we had, and we can do a substitution, right? This is all equality stuff. So I can take this, AB plus BC, and I can now replace it with AC. And say, hold on a sec, this stuff, we're going to rewrite this statement down here. This stuff is just AC, right? And this stuff right here, that's just BD. Okay, let's do it in blue though. So we're gonna erase some of our red stuff here. This is kind of the work here. So our next statement will be AC equals BD. Okay, we'll get rid of this. This is just for us to kind of show our thinking here. But that was a substitution property of equality. We replaced a statement with what it was equal to. So we're going to go substitution prop of equality. Okay, so we'll abbreviate here. And then how do we get from here to here, the last statement that we want? Well, we're going to use the definition of congruence. If two segment measurements are equal, that means the segments that we're talking about are congruent to each other. That's the definition of what congruent is. So def of cong. Okay. So that's, again, we did that before. We did this last week on our segment proofs, like part 1. Okay. This is the same proof in angle form. Okay, that's what I'm trying to point out here. So let's see if we can walk through this and compare it to what we had before. Okay, let's start off with the given here. So we know that angle 1 is congruent to angle 3. Well, what does that even mean? It means their measurements are equal, right? So when we start with a congruent statement, the next statement we have is usually an equality statement, right? Definition of congruence. Okay, no problem. We got it. Okay, now what we can do in this step, now this step doesn't have to come right after this one, it can come later if we want to, but we're going to just kind of mirror this one. So if I have an equality statement, what I can do is I can add something to both sides, right? This is just some equation, essentially. So I'm allowed to do something like this, plus 5, right? Addition property of equality, okay? But instead of having plus 5 on both sides, which doesn't really make sense in this context, what I'm going to do is I'm going to add the measurement of an angle. So plus measure of angle 2 plus measure of angle 2. Right? Now why I'm doing that right now doesn't totally make sense. It will in a second when we do a substitution. And again, this step doesn't have to happen right here. It can happen later, and some of the orders of these steps don't have to be exact. There's also maybe other ways to go about proving this. But the next line we're going to have here is going to be the measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. Also, sorry, this should say the measure of angle 3. Let me rewrite that so we can fit it all. The measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. All we did was add the measure of angle 2 to both sides of this equation. And again, it may not be super obvious why we're doing that right now. We're going to need that statement in just a second. This is the addition property of equality, right? Just like we had over here. Same idea. Here we added a segment measurement on both sides. Here we're adding an angle measurement on both sides. Okay? All right, the next thing we're going to do is we're going to use the angle addition postulate. So segment addition postulate says a segment that's made up of two other segments. If you have that, then the measure of the small one plus the measure of the other small one equals the big one. And that's what we have here. So notice that if I add angle 1 and angle 2 together, I get angle CBD. Right? So what I'm going to do is the measure of angle 1 plus the measure of angle 2 equals the measure of angle CBD. 1 and 2 gives me the red one. Okay? And that is the segment addition postulate. Okay? Likewise, the measure of angle 2 plus the measure of angle 3 equals the measure of angle EBA, the blue one. Same reasoning. It's the segment addition postulate. Okay, do you see what's going to happen now? Over here, once we had these two statements, we just replaced this and this with this and this. We did a substitution. So, what is the measure, or excuse me, right here, measure of angle 1 plus measure of angle 2? Well, that's just this. Measure of angle 2 plus measure of angle 3? Well, that's just this. Alright, so what I can do is I can take this statement and rewrite it, but substitute. Okay? So instead of measure of angle 1 plus measure of angle 2, what should I write? This guy. Measure of angle CBD. Okay, so just so we're clear here, this angle is getting, these two angles is getting replaced by this guy. Okay, oops, sorry, my hands are kind of sweaty, so I'm like, can't open the cap. I just drank a bunch of Coke and I'm all hopped up on caffeine and sugar. So it's fueling my, my work from home experience. Alright, these two guys, angle 2 plus angle 3, right, I can replace with this guy, the measure of angle EBA. So this stuff is getting replaced with the measure of angle EBA. Okay, and that's just the substitution property again. Substitution prop of equality. Okay, and then the last step is, oh, hold on, if two measurements have the same, if two angles have the same measurement, then they must be congruent. So now we can say angle CBD is congruent to angle EBA. Definition of congruence. Definition of angle congruence more specifically, but we're okay with that. So hopefully you can see now that these proofs are basically the same, right? The same structure, okay? They're practice using the, holy smokes, I said segment addition. This is angle addition. Hope you guys caught that. Angle addition postulate. Right, so very similar to this guy, but we're talking angles here. Right? We can't just copy it exactly over, but we translated it to the angle version. So if you understand this proof from last week, which I hope you do, then this proof shouldn't be any more difficult. You just kind of translate it. Okay. The next problem, problem number 6, is going to be basically this problem in reverse. So we're going to start with this, and we're going to have to prove this, or something like that. The image, the figure is a little bit different the way it's labeled, but very similar. So I'll do that one with you in the next video, and yeah, so check that one out.